Hello everyone. Let's practice with hypothesis testing. Assume that a population has a normal distribution with the variance equal to 64. So we have a population, just one population, and this population has a variance equal to 64. Okay. So we take a sample with size 16 from this population. Okay, so we take a sample with size 16 from this population and find out that the mean and variance of the sample are 20 and 5 respectively. So X bar from this sample is equal to 20 and variance, but here we should show it by S2, not sigma, because it is related to sample. S2 is equal to 5. Okay. We are interested to estimate if the mean of the population is equal to 23. So mean of the population, we are talking about that. When we talk about equality, I mentioned that for equality case, let me show it like this. It's better to consider it for H0 and for not equal case for HA. For less than, more than that, then we explained it also in the lecture that these are other possibilities that can happen. But here we are talking about the equal. So it means that your test should be two-sided from the beginning. So 23 here is actually mu0, right? The one that we explained in the lecture. And we want to run this test by 95% confidence level. What does it mean? It means that your alpha is 1 minus 95%, which is 5%. Okay, all of these are just the assumptions. So check this by running a hypothesis test using now 3 different questions, 3 different methods we are going to use to solve these assumptions. Okay. So there are some assumptions. Actually, there's a question. So we want to solve the question related to those assumptions. So as I said, null hypothesis should be defined like this and alternative hypothesis like that. Why I don't consider this one as H0? Because I explained it in the lecture that for rejection area, it's better to be on the right and left side. So the middle should be acceptance area. You see in the picture, it's also obvious. So we are dealing with two-sided. Why? Because we are talking about equal or not equal. In case of more than, less than, we have only one-sided test, which we also explained in the lecture. Alpha, we also mentioned how to calculate it in the previous slide. Now I want to run the test using test statistic. It means that I should find Z0 or T0. But which one of them we are talking about? Can I use normal distribution or T-student? So take a look at our assumption. So I already explained about the cases. And when we are talking about one population, we had 4 cases, if you remember. So we want to estimate the mean of the population, and this is just one population that we are talking about. So there are 4 cases. Look at our assumption. The variance is given. I know the variance of the population. This is 64. So when it happens, and I know that my population is normally distributed, I can use normal distribution. Okay, so I can use z-test. That's the reason here I use z0. Is it z0 for the case 1 or case 2? This is case 1 because I have the value for sigma. The thing you should be careful, this formula, first of all, is given. You should use such formula in your solutions, but Next, you should be careful when you assign value for this sigma. Sigma here is the standard deviation, not the variance inside the formula. So if variance was equal to 64, so what is standard deviation? Of course, this is equal to 8. So don't be excited to put 64 here, because it happens time to time that students put variance instead of a standard deviation in this formula. Okay, so the value happens to be minus 1.5. So this is your test statistic. In case when H0 was less than or more than, then it's very easy to just compare it and to see whether it falls inside the rejection area or not. But now we are talking about two-sided case. It means that half of the rejection area is on the left side, half of it is on the right side. So when you find Z0 equal to minus 1.5, is it here or is it here? That's why I should find Z alpha in order to find this value, so that's the final answer. So Z alpha over 2. Why over 2? Because we are dividing our rejection area into half. One on the right side, one on the left side. So what is the name of this part? This is 1 minus alpha over 2. Okay. So I'm interested to see Z0 is more than that or less than that. If it is less than that, based on the picture, it's obvious that we should reject H0. If it is more than that, then there are not enough evidence. So what is alpha? Alpha, we know that this is 5%. So the final answer for alpha over 2 is 0.025. So I should find z-score corresponding to that. For both sides, you can do that. You see? Why is that? Because, of course, minus 1.5, directly I would understand that this is less than 0, and for sure, it is going to be less than this value anyway, because it was negative. But the correct way, in order to find it for two-sided test, is better to calculate both of the z-scores from the right side and the left side. So this part is alpha over 2. This part is 1 minus alpha over 2. What we should check is that, is this value between these two z alphas or not? If it is the case, then we should accept H0 because there are not enough evidence to reject it. So with 95% confidence level, we say that. But let's say if your test statistic happened to be minus 2, then minus 2 is less than 1.96, then you reject your H0 with 95% confidence level. But if, for example, if it was 2, then again, you should reject it. This time you compare it with 1.96. That's why it's good to calculate both of them. Once for Z alpha over 2, once for Z 1 minus alpha over 2. This one is a positive value, this one is a negative value. Why is that? Because a standard normal distribution has mean equal to 0. And this is a symmetric distribution. So for sure, I know that whenever you find a positive value, it means that it should be on the right side of the distribution. When this is negative, on the left side. These are the things that you should practice with the table so that we won't have mistakes, okay? But for this question, we should accept H0 because it falls inside the acceptance area, okay? So 1 minus 1.5 is somewhere around here. What if we want to run the test using p-value? The last one was using test statistic. So for this one, first I need to calculate Z0 anyway, our test statistic. So here I have no other choice to find my z0, which we found here. So z0 is minus 1.5. It means that this probability is equal to this one. You already know how to find such probability. The probability of z less than minus 1.5, right? So you may say in our paper that we usually receive the tables related to positive z values. When it is negative, what should I do? Then I told you also about this one before. Then you can calculate it using the complement because we have a symmetric case. So when we talk about normal distribution, this probability when you have 1 minus 1.5, and here we have 1.5. From the table, you can only find the cumulative for the positive z values, right? If we had the table for negative values, then you could use it. But in the exam, as we said, we always have the z plus case. So in this scenario, I cannot read this one directly from the table. Then I use 1 minus p z less than this. And by using that, I can find the p-value. But why do you multiply it by 2? I explained it in the lecture before that whenever this is a two-sided case, you need to multiply it by 2. That's why when you want to compare it with alpha, then it will make sense. Okay. So as you can see, even for testing with p-value, you need to find z0 first. So first use this formula. So for your complete solution, you should use this formula, then assign it here, then find the probability, and this is your p-value at the end. Now that you found your p-value, compare it with your alpha. You already found alpha before. So for your complete solution, again, you should mention about alpha. You found out that this is 5%. And as you can see, your p-value is more than that. What can I say when it happens? When p-value is more than alpha, then there is not enough evidence to reject it. In the case that, for example, if p-value would be 1%, then in that case it was 5%, then you could reject it. Otherwise, it's not possible. Okay. So for alpha and p-value, based on the method that I taught you, it's very easy because always alpha should be p-value should be less than alpha in order to reject the null hypothesis. Otherwise, there's not enough evidence. But for z-score, it could be a little complicated because you should imagine the graph. Then based on the graph, you should decide whether this z0 falls here or here. Okay, it could be more tricky sometimes. But if you practice, all of them are very easy. Okay, about the confidence interval. So there's another way that I wanted to talk about during tutorial that you can run hypothesis testing. From the previous tutorial, you know how to construct confidence interval. So I'm not going through this part of solution because you should know based on the previous lectures. So first, as we did before, just construct the confidence interval for this example. And the cases are exactly the same like we explained for hypothesis testing. For confidence interval, this is the same. The only thing is that for confidence interval, the formula is written like this for lower bound and upper bound. We don't have such a thing like test statistic anymore, right? We want to use confidence interval. So here we reach this one as the final answer. So assume that this is your confidence interval. What was null hypothesis and alternative hypothesis? So you should write them for sure in order to decide. So null hypothesis was whether mu is equal to 23 or not. Null hypothesis is equal to 23 and alternative one is not equal to 23. So this is null one, this is the alternative one. Now, you found out that this is the confidence interval based on alpha. So 1 minus alpha, it is your confidence level, which is 95% in this example. If I change this confidence level, then you may find other results, and based on that, you may reject or accept null hypothesis differently. We should also be careful with that. So you can also practice by just changing the value of alpha. Anyway, so let's say you know how to find the confidence interval by knowing what is alpha. Then check it whether 23 falls between these two values or not. If this is the case, then you don't have enough evidence to reject null hypothesis. But if the value that here you have as mu0, if mu0 is less than this one or more than this one, then you should reject H0 with 95% confidence level. Okay? And whenever I ask questions related to running tests for confidence interval, I give you two-sided cases because it is more meaningful. Otherwise, we usually don't use confidence interval for one-sided cases. And this one is mostly used for that. So in the exams, please guys be careful that which type of hypothesis testing we are applying. Is it a test statistic? It has another method. P-value, you should compare it with alpha. Confidence interval, you construct a confidence interval, then compare it with your mu0. So the methods are different, but always they should give you the same answer. It means that at the end, for all of them, you should accept H0 with 95% confidence. If you find another answer, it means that your solution was not correct for one of them. Okay. So I think this tutorial was useful for you, but as I explained also in the lecture, there are so many cases, there are so many possibilities. We have just one book for hypothesis testing for statisticians. That's why now that we have only 1 week to cover everything for hypothesis testing, you guys need more practice with it. It means that please go through the questions in the book, and especially with the ones without solution, because as I mentioned, those solutions are not necessarily acceptable for our exams. There are some mistakes there. The methods sometimes are different, but I explained everything in perfectly, and you can know how to deal with each case accurately. So if you read the lecture carefully, if you go through the tutorial that we had today also carefully, then by practicing more on those questions, you will be comfortable with hypothesis testing. But guys, I'm telling you that it takes time. It means that from now you should practice. If you wait until practical assignment 2 or final exam, that could be late. So from the exact week that we have hypothesis testing, start practicing so that finally you will be ready when it will be the time for practical assignment and final exam. And of course, if you cannot solve any of questions in the book, as I say, especially those ones without solutions, so please let me know in the office hour or using an email. Also, for those ones who have solution, but it differs from our method, then you're not sure whether you can solve it correctly or not. Again, you can check it with me for sure. I would be more than happy to answer your questions about hypothesis testing, because this lesson is the most important for data analysis. And as soon as you are comfortable with hypothesis testing, it means that you know how to finally conclude something and finally report your information. So all we have in statistics are data, and we try to extract information from it at the end. If you don't know how to run hypothesis testing, then you will be limited only to summarize your data using plots. Okay, guys, I hope it was useful and see you guys in the next session. Bye for now.